kind of facility now at Brown University. Okay. And at Ames, we have a couple of facilities that we share as well. There's a regolith test bed where we have 8 tons of simulant, of lunar material, and we have little rovers that run around in this yard. I use it with students remotely across the world, and they can operate the rover, and we built in little lessons where they can go up and try and identify the difference between a meteorite and a rock, take pictures of it. There are scientific uses for the test bed as well. And at Stony Brook University, there is a vibrational spectroscopy lab. And this is, again, something where people would bring their samples to it and try and understand, or something that they've built or created, try to understand more about how it would interact with or be interacted on by some sort of process. Also what it's made out of. Okay, another part I wanted to stress is the survey team collaborations that we have across the team lines. And so just a couple of examples. This first one came about in the very first experience where we brought the principal investigators together to meet for the first time. And over this 2-day period where they met face-to-face, we were at NASA Ames, we asked them to please come up with a list of areas where they thought their area could cross over and they could find a collaboration with one of the other teams. We had each of the teams give a little synopsis of what their proposal was. Now keep in mind, these were teams that were competitors just moments ago, and now we're asking them to share everything. Share your data, share your processes, tell us what you're going to do, and look for ways, trust each other, and look for ways to work together. And they did it instantly. And one of the ideas that came out of it was to have this sample repository at the Natural History Museum, where any team that collects any kind of field sample or had a sample that they made could bring it together and put it in one place, so that if you wanted to do some sort of process on it, you could know that you were using the same rock. 2 different teams doing 2 different processes on the same sample is a lot better than using 2 entirely different samples that you just happen to think are the same rock. And this one ran into just a little bit of a hiccup because it turns out the Natural History Museum does not take samples that are found on Earth, but they only take samples that you create. So we're looking for another home for the actual field samples at this point. But this was a great idea, and they started putting all their materials together right away. And I was just really pleased to do that, to see that happen. And another one is the asteroid modeling. So the dynamics that we talked about with the early solar system and what happened to it when you had all this bombardment in the early days, when you couple that to geochemical studies of the rocks that people have found, either from meteorite samples that have come off planet, from someplace else, or the lunar samples that came back from the moon, you couple that together with the dynamics and you can learn an awful lot about what happened when. And what we call the late heavy bombardment period that affected both the Earth and the Moon system is one of those times that we'd really like to understand better, because it looks very, very likely that the Moon formed out of a giant a Mars-sized body hitting the Earth. And when it hit the Earth, it knocked off a great deal of material, and out of that formed the Moon. But what didn't make sense for a long time were the isotopic studies that we had and the chemical composition between the Moon and the Earth. Those are now coming into much clearer focus in terms of how hot the the Earth was, how wet the Earth was, how big that body was, what kind of angle that body had to hit the Earth at in order to make what we end up seeing on the Moon. So it's just amazing that dynamicists and geologists getting together are making these kind of strides forward. I mean, those people would not even have gone to the same conferences. So they wouldn't have met, they wouldn't have taught, they wouldn't